Good day, viewers all over the world. I welcome you to class today. We shall be looking at normal distribution. It is a continuation of the series we started on probability distribution. I want to thank my viewers that have subscribed to this channel. Thank you for subscribing and also sharing my videos in all social media platforms. And for those of you who have been benefiting from the channel and you are yet to subscribe, please subscribe to this channel, share my videos in your social media platforms. The essence of this channel is to share key knowledge in statistics and mathematics across the globe, in numerical analysis and applied statistics. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor degree in statistics. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I grew to that position in January 2023. And I've been privileged to also work with 3 AI firms in the United States of America. I did remote jobs with them where I assisted in training their AI models as a mathematics specialist, as a mathematics expert. I'm also a statistician. So if you're an AI firm, you want to reach out to me to be part of what your team of mathematicians or statisticians is doing, you can contact me on +234 80 21903. This first contact is for call and WhatsApp. Then you can also reach me on +234 70 This second contact is for call only. Then my email is chrisdavid2015@gmail.com. Thank you very much. Permit me to claim my contacts. I'll be expecting to hear from you as we go quickly into the business of the day. And today we are looking at the normal distribution. The normal distribution. The normal distribution is a continuous distribution which is mainly referred to as the cornerstone of modern statistical theory. This is the cornerstone behind the development of statistical theory, and from the beginning of the series, which is a probability distribution, I talked on probability distribution, the meaning, and I also talked on random variables, the types of random variables, discrete and continuous random variables. You know, a probability distribution is either following a discrete random variable or a continuous random variable. We looked at the Bernoulli distribution. The Bernoulli distribution follows the discrete random variable because the number of terms can be counted. We also looked at the binomial distribution and also the Poisson distribution. We also look at the Poisson distribution as an approximation of the binomial distribution. Today we shall be looking at the normal distribution. The normal distribution follows a continuous random variable. A continuous random variable is a variable whose values are given within a given interval, while the discrete random variable has a countable number of terms, finite number of terms. The terms can be counted. So now the normal distribution follows the continuous random variable. So a continuous random variable x has a normal distribution if the probability density function PDF is given by. When a probability distribution follows a discrete random variable, that probability distribution has a probability mass function. Please, you need to understand the difference between a probability mass function and a probability density function. Probability mass function is for the probability distribution that have discrete random variable, while probability density function is for probability distribution that follows the continuous random variable. So the normal distribution follows the continuous random variable. That's why it is having the probability density function PDF. So the PDF of the normal distribution is given as f of x equals 1 all over square root of 2 pi sigma square. Sigma square is the population mean. The population variance then exponential raised to the power minus half into x. X, of course, is the value that the continuous random variable will take. Then mu is the population mean. Mu is the population mean, while sigma itself, of course, is the population standard deviation. Is the population standard deviation. So this is the probability density function of the normal distribution. And of course, the continuous random variable takes value between minus infinity to plus infinity. So minus infinity is less than the random variable x, and it is x is less than the plus infinity. So the population standard deviation, which is sigma, is strictly greater than 0. Is strictly greater than 0. So a normal distribution is completely defined if the mean mu and the variance are known. So the mean mu and the sigma square, which is the variance, are known. So you define the normal distribution completely when the mean is the population mean, is known as mu, and the sigma square is the population variance, is also known. When the two of them are known, then the normal distribution is completely defined. Now, for the sake of computation, the probability density function is transformed into a standardized form. So the PDF is transformed into a standardized form. This is the standardized form. This is the standardized form, and it's written as Z. That's why the normal distribution is also called the Z distribution. So it's equal to Z. Z equals to X, which is the random variable, minus mu, which is the population mean, all over sigma, which is the population standard deviation. So that is the standardized form of the normal distribution. So this now means that I don't need to clean this part. So the sigma square is the population variance, while the sigma is the population standard deviation, and the mu is the population mean. Now, in standardized form, we have Z. That's why the normal distribution can also be called the Z distribution. And of course, for the normal distribution to be complete, you must know the mean, the population mean, and the population variance. Population variance is sigma square, while the population mean is mu. This is sigma square, the population variance, and this is mu, the population mean. They must be known. When they are known, then it is in the complete form. Now, the standardized form of the normal distribution is x minus mu all over sigma. Thus, we are going to have this probability as this probability of into A less than X less than B, and this is also equal to probability into Z subscript A, Z subscript A less than Z itself less than Z subscript B. So you have this like that. So this will now be simply written as F of, because these probability values are going to be gotten from the normal distribution table. This will be F into Z of B minus F into Z of A. That is what this means. So this is an interval. X is taking value within the interval A and B, and of course the Z of A less than Z, then less than Z of B. Then now to get the probability value, you now take the Z value of B and the Z value of A, subtract that of the Z value of A from that of the Z value of B to get the probability you are looking for. So in simple terms, this can now be written as F into, now for the z of it will now be B minus mu following the standardized form minus mu all over sigma. Then of course this minus sign is there. F of course into, of course A is here to be A minus mu. Mu is the population mean all over sigma, which is the population standard deviation. So this is how you have this. So when you calculate this value, you look at for the probability value from the normal distribution table. Then you calculate this value, you look for the value from the normal distribution table. That is the area under the standard normal curve. So under the statistical table, we have what we call the normal distribution table or the Z table. That from there you'll be able to look at the area under the standard normal curve. So this is the standardized form of the normal distribution, and this is how we are able to get values for the probability values within a given interval. So permit me to clean this so that we can take the characteristics of the normal distribution. It is good you understand what the normal distribution is. If you understand the characteristics of the normal distribution, it will be easier for you to apply it in solving any problem you are faced with. So now we continue. Let's look at the characteristic of the normal distribution. The characteristics of the normal distribution. Now, the first characteristic is one, the mode which is the point, the mode which is the point on the horizontal axis, point on the horizontal axis where the curve is maximum, is at x equals to mu. The mean mu as x equal to mean and median. So there is a normal distribution curve. Permit me to draw it. It's just like you have your x-axis. The curve goes like this, like a bear, like this, like a bear. So this is the curve, and you can see at the maximum, it said the mode, which is the point on the horizontal axis. Now, where the curve is maximum at, now look at it now at the median, the middle value. So it's at x. Of course, you know this is the x-axis and this is the y-axis. So the middle of the curve is like the normal curve, the normal distribution curve is like a bear. And look at the middle here. At this particular point, this is the height where the curve is maximum. This is the maximum. So the middle of it, at this point, our x is equal to mu. Our x is equal to mu. So you can say this is the height, which is the mode, the highest point in the curve. At this particular point, that is the highest point in the curve. Then the middle of it is the median and also the mean. It's also the median and it's also the mean. So this particular middle of x is called the median and it's also the mean. So that is the first characteristics of the normal distribution. It has a curve. That means, you know, the mean, the mode, the median, they are measures of central tendency. That means they are the same. So these three measures of central tendency are the same. Look at the peak. the maximum of the curve, and that is where the mode lies. The mode is at the maximum. Then the middle of it is the median and at the same value of the mean. So that means the mean, the mode, the median, which the measures of central tendency are the same for this normal curve. That is what that point is explaining. Then characteristic number 2, the curve is symmetrical. The curve is symmetrical. The curve is symmetrical about the vertical axis. Is symmetrical about the vertical. Is symmetrical about the vertical axis through the mean. Through the mean. So you can see that the curve is symmetrical about the vertical axis. So you should know the vertical axis is symmetrical about through the mean. So that is a characteristic. Then characteristic number 3, you have that the total area under the normal curve and above the horizontal axis is equal to 1. The total area about the normal curve, and the horizontal axis is equal to 1. Is equal to 1. So the total area under the curve, is 1. The total area about the normal curve and the horizontal axis is equal to 1. And we all know that when the probability of an event is not greater than 1, and of course the sum of all probabilities is also equal to 1 when you are dealing with sample space. So the normal distribution obeys that law. Then point number 4, or you can call it characteristic number 4, is that the normal curve approaches the horizontal axis. Of course, you know this is the horizontal axis, then that is the vertical axis. The x axis is the horizontal axis, while the y axis is the vertical axis. So the normal curve approaches the horizontal axis asymptotically. Asymptotically as we proceed in either direction, away from the mean. So it's very simple. So you can look at it now. It's the same length here, the same away from the mean. Look at the mean is the middle, and the median. The mean and the median are the same, and of course look at the mode there and the middle of the maximum of that particular part of it. So the normal curve approaches the horizontal axis asymptotic, and that's what it means. Look at it, the way it goes like this up, and it's the same length from like this to like this, and the same way it approaches from this, from both ends, and it approaches the mean from either direction, from this direction and from this direction. So these are the characteristics of the normal distribution. It is as simple as this. These are the characteristics of the normal distribution. So take note of it that the total area about the normal curve and the horizontal axis is equal to 1. This will be helpful. Now it is time for us to take a practical example and see how we can apply this. So permit me to clean the board so that we can go ahead and take a practical example and see how we can apply this to solving a real life problem. The essence of all this is to solve real life problems. So now let us take an example. This is an example. The example says, it was observed that the average distance, it was observed that the average distance from the average distance of one bank to the other of one bank to the other, of one bank to the other is 120 meters, and the standard deviation is 12 meters, and the standard deviation is 12 meters. Now, assume the distance is normally distributed. Assume the distance is normally distributed. It's normally distributed among the various banks in the area. Normally distributed among the various banks in the area. Calculate the probability that a bank chosen at random will be located, that a bank chosen at random will be located A, between 100 and 130 meters, between 100 meters and 130 meters. B, more than 125 meters, more than 125 meters. And C is at most 140 meters, at most 140 meters. So this is the question. We go straight to the solution. Now the solution is simple. Here we need to understand that we are told that when dealing with the standardized normal distribution or a completely defined normal distribution, the mean and the variance of the population must be known. So you can see for this particular problem, the mean, which is the mu, from here mu is equal to 120 meters, and our sigma, which is the population standard deviation, is equal to 12 meters. So, and remember, our standardized normal distribution is transformed into x minus mu all over sigma. So that is what it has. Now for us to solve problem A says calculate the probability that a bank chosen at random will be located between 100 meters and 130 meters. So this simply means that the probability is between 100 less than x less than 130 meters from A. That is what the problem is. And if you want to take it this form that it was written, this will be equal to probability into z of A less than z of B. And if you want to continue, then definitely this will now definitely be f of zb minus f of za, and that will be equal to, of course, from here we know that our A, from here our A is 100, our B is 130. So this will be f into x minus mu all over sigma, then you cover it, then minus f, of course, okay, let's put the B here, then into A minus mu all over sigma. So this will be equal to, now when you have this, we are going to have our f into, what is our B? Look at it, our B here is 130, so it will be 130 minus, what is our mu? Our mu is, what is our mu? Our mu is 120, so it will be 130 minus 120 all over, what is the sigma? Sigma is 12, then you cover it, minus f into, what is our A? Our A is 100, it will be 100 minus 120 all over, what is our sigma? 12, then you cover like this. So when you take this, you are going to have f into, now you are going to have 130 minus 120, that is 10. 10 divided by 12, 10 divided by 12 will be 0.833, 0.833, then you put a minus sign, then f into, now the second one is, you have 100 minus 120, it will be minus 20 over 12, that will be minus 1.667, minus 1.667. Now, beloved, we need to go to the area under the standard normal curve. So you need to visit your statistical table now. There is a table called the Z table or the Z distribution. That table looks like this. Let me just give you a view of what the table is. You have it like this. Here is Z. You start here with 0, 0.0, here will be 0.0, 0.1, 0.2, 0.3, down here will be 0, 1, 2, 3, 4, down to 9. You have it like that. And there are probability values. You see, we have two types of the Z table. There is the Z table that ends with 0.4999, which is approximately 0.5. That is the highest value. All these values here are probability values. Just locate the Z, it's called the standard Z table or the standard Z distribution table or normal distribution table. You locate it. Now from here, that's where we get the values of F. These F are probability values from the Z table. Now there are two types of Z table. We have the Z table that ends with 0.5, but the total area under the curve is 1. There are some that the one that ends with 0.5, that means you are going to be adding 0.5 to each. For instance, if I have 0. Like under 0.3 under 0 is 0.1179. This is the value now. For instance, this is the value 0.1179, and this is the value under. If I want to check, for instance, if I have f into 0.30, now look at it now. The table value from, I'm giving you an example on how to check. If you check that table value, the Z table value, you will see under 0.3, under 0, you will see values under these numbers down to this particular one, to the highest value down. It goes down from 0.0, 0.1, 0.2, 0.3 down to 3.9. So now I'm taking this as an example so that you know how to check. This table now is under 0.05. But the total area under the normal curve is 1. So now that means for each value here, I'm going to be adding 0.5 for this to be 9, for this to be 1.0. The total area under the curve is 1. So this one that ends at 0.5 is half the table. That means each probability value must have 0.5 added to it. Now this particular value here now, if I want to get, you can see 0.3, I will check 0.3 under 0, which is 0.1175. So it will be 0.1175, 0.1179. I'm not going to write this, but because this table ends at 0.4999, which is approximately 0.5, I will add 0.5 to it. So my F value for 0.30 will now be equal to 0.6179. But if you go and check the table that ends with maybe 0.9999, which is approximately 1. So the standard normal curve is 1. The total area under the standard normal curve is 1. So if you come across the second type of table which ends with 1 or 0.9999, this value here will not be 0.1179. It will not be 0.6. So you check this one. For this particular one, you don't need to add 0.5 to the table. You don't need to add 0.5 to the table. That's how you check it. So there are two tables. There's one that ends with 0.4999, which are probably 0.5. For each value, you'll be adding 0.5. But there is one that ends with, that's what you will check first, where the table ends. It must not exceed 1. Because the total area under the normal distribution curve is 1. So if it ends with 1, you use the value directly. If it ends with 0.4999 or 0.5, that means you are adding 0.5 to each. I just give an example so you can see. If it is this one now, you can see 0.6179, which is this one. So you don't need to add 0.5 here because it ends at approximately 1. So take note of that. That is how you check the normal distribution table. So the F value is easy to get. So I've used this as an example. So if you come here now, so I will prefer for you to get a table. Look for the table that has up to 0.999 or 1.0 approximately. Get that one instead of looking for the one that is half, that is 0.5, that you'll be adding 0.5 to each probability value. So if I come here now, you will see that from here, I am going to have, I will check the probability value. I will now go and check 0.8 under 3. I will check 0.8 under 3. If I check 0.8 under 3, I'm going to have 0.79, 0.7967. That is what I'm going to have directly. Then, of course, this minus sign is here. But you can see because this F is having a negative value, F of minus 1.667. This is equal to 1 minus, because of this minus sign here, it will now be 1, because the total area under the curve is 1. It will now be 1 minus f of 1.667. So anytime you want to check the f value, the table value for z with a negative number, what you need to do, if it is having a negative number, it will be 1 minus the f of that value. So that negative number will be out of it. The negative sign will be out of it. So you now come in, you now have 1 minus, you check f. How do you check it now? You can see, you can just check 1.6 under 7. This one approximately 7 now. So you check the lines like I told you. You have the lines like this. You have the z 0.0, 0.1, 0.2. This is 0, 1, 2, 3, 4, 5 down to 9. So you just trace 1.6 under. Of course, this one is approximately 1 to 7. 1.6 under 7, just go down 1.6 under 7, and the value there is 0.9525. 0.9525. So when you subtract this from this, you are going to have f of 1 minus 1.667 equal 1 minus 0.9525, and that will give you 0.0475. That is what you are going to have. So now, coming here, I just solve this value out because of this negative sign. So coming here now, I'm going to have this value as this probability value. So this will be 0.7967 minus 0.0475. Then when you take that, you are going to have 0.7492. 0.7492. That's what you are going to have. So you can see I've been able to get this one. So when there's a minus sign, it will be 1 minus that. So permit me to clean that off. So the question A has been solved. Question A has been solved. That is the answer for question A. 0.7492. 0.749. Now for the question B says more than 125 meters. So it will be P into X is more than, that means S is greater than 125. That is what it means. And if F is greater than that, of course we are going to have it as P into Z greater than ZA. So if you have it that way, you are going to have it as equal to F into A minus mu all over sigma. That is what you are going to have, into A minus mu all over sigma. So here now our A is 125. So you are going to have 125. That means you are going to have F into 125 minus, what is our mu? Our mu is 120 all over sigma. Sigma is 12. So you have this like that. So coming here, you are going to have, now carry out this calculation. You are going to have F into 125 minus 120. That will be 5 all over 12. When you take that arithmetic, you are going to have F into, you have 5 over 12. That will be 0.417. 0.417. So you now go to the Z table, the total area under the standard normal curve, the Z table, the normal distribution table. What you just need to do, check 0.4 under 2. This is approximately 2. Check 0.4 under 2. You are going to have 0.6628. That's what you are going to have. You are going to have 0.6628. That is the probability. You check 0.4 from the row on the vertical side, then on the columns check under 2. You will have this particular value. So now let us solve question C. Permit me to clean this part as I solve question C. Question C says at most 140. At most 140. At most 140. That's what question C says. At most 140. So we are using this phrase to solve for question C. Question C says at most 140. So what we need to do here now for question C, C says at most 140. So that means the probability will be the value of x will be less than 140. That is at most. It's less than or equal to. So at most 140 is simply when it is less than, this will now be equal to 1, of course, minus probability of having it as, for you to turn to greater sign, 140. So you have to turn it to greater sign before you can use the standardized normal. So if it is less than, for this less than to become greater than, it must be 1 minus that, because the total area under the curve is 1. The total area under the curve is 1. And that will now be equal to 1 minus probability of z greater than ZA. That is what it means. So if you have that, so it simply means that you're going to have 1 minus f. Of course, you have it like this: A minus mu all over sigma. That will be 1 minus f into, what is our A here now? Our A here is 140. So our A here for this particular problem is 140. So you have 140 minus, what is our mu? Our mu is 120 meters minus 120 all over our sigma. Our sigma is 12 meters. Beloved, we are on the third question, question C. So you can see that question C says at most 40 meters. At most 140 meters. At most 140 meters. That is what question C says. So it means that at most means x is less than or equal to 140. And of course, if you want to turn this less than to greater than, you have to subtract it from 1. And you know that the total area under the normal distribution curve is 1. So it will now be 1 minus probability of x greater than 140, because it's less than 140. So you cannot use the standardized form of the z distribution when x is less than. So at most means the highest it can go less than or equal to 140. So we always write that x less than 140. So to turn into this standardized form, because the greater than sign is for the standardized form. So to be s greater than, for it to be s greater than 140, it must be 1 minus that, turning this less than into that. So it is equal to as 1 minus probability of z greater than z of a. Of course, our a here is 140. So we are going to have 1 minus, of course, this is the standardized form. Our a is 140 minus, of course, our mu is the mean of the problem, which is 120 meters, and our sigma is the standard deviation, which is 12. So having this will now be 1. Of course, having this, we are going to have it as 1 minus f into 140 minus 120 is 20 all over 12. So this will now be equal to 1 minus f into 20 divided by 12 is 1.667. So you have the bracket, you have 1.667. Then you cover the bracket. Then when you come here, you are going to have 1 minus f into 1.667. Then again, you go to the, you have 1 minus, you go to the z distribution table, the normal distribution table. All you just need to check from the rows, of course, make sure that the last value on the probability value is 0.999 or 1.0, because the total area under the normal distribution curve is 1. So the last value there will be 0.999 or 0.999 or 1.0. So make use of that one instead of using the other half table as I explained. The half table will end with 0.4999 or 0.5. That means you need to be adding 0.5 to each value so that the last value will be 0.999 or approximately 1.0. The total area under the normal distribution curve is 1. So now you check 1.6 under approximately 7. You are going to have, if you check that, you are going to have 0.9525. It will be 1 minus 0.9525. So when you carry out this subtraction, 1 minus that, you are going to have 0.0475. 0.0475. Beloved, you can see that we have come to the end of this particular exercise, and I'll be stopping here for today. We have looked at the normal distribution, the characteristics of the normal distribution, the probability density function of the normal distribution, the standardized form of the normal distribution, and also, of course, we are told that the normal distribution, for the normal distribution to be complete, the mean, the population mean, and the population variance must be known. And for this particular problem, the population mean is 120 meters. The population standard deviation, of course, from the variance you get the standard deviation. The population standard deviation is 12. And again, you can see that the standardized format was used, and then the problem was easily explained. Beloved, if you have any challenge with this problem, put it in the comment section and it will be attended to immediately. And for those of you who have not subscribed to my YouTube channel, you have been benefiting, please subscribe to the channel and God will bless you. And for those of you who have subscribed, keep sharing the videos across your social media platform, and as you do that, God will richly bless you. For you that are postgraduates and undergraduate students, I attend to you freely. You can send me a WhatsApp message or an email, and it will be attended to. And if you're an AI firm or a research institute, I'll be looking forward to hearing from you. My contacts and my email are at the beginning of this video. God bless you. Thank you for watching the video to the end. Enjoy the rest of the day. Bye.